Now Andrés Díaz here from the Theoretical Physics Institute in Madrid is going to show us an agile status installation of a cluster with OpenHPC. With some demo, I think, or something like this.
Okay, yeah. Thank you, Enio. And thanks to the organizer for letting me be here. And well, there was a lot of big systems today. So I'm gonna talk more about small and medium-sized systems, like the one I have in the IFT. And the first thing I have to say is that I'm not, an employee of OpenHPC. So I just want to tell you about my user experience with this piece of software. And I've been using it for almost a year, and we are pretty happy with it. So this is the overview of my talk. And first I will tell you about my motivation to be here. And after that, I will introduce a little bit my home institution, what we do in there, and what we are. And after that, I will review or make an overview of all OpenHPC features. And after that, I will present what I believe is the most important part of this talk, which is a live demo, well, almost live demo, and some conclusions after all. So my motivation to be here is that, once upon a time in a far away country called Spain, some people, mostly politicians, thought that it could be a good idea to have a lot of machines running in the country, okay? But they also thought that it was not so good idea to have people to take care of those machines. So people are nodding like this, huh? You know that. And now the situation is even worse. I mean, now we don't have money for people, and we don't have money for more machines. So the machines are getting older and older, and this translates in more and more many overwhelmed sysadmins. You know, I know a lot of research centers and university departments with small or medium-sized clusters that are stuck with CentOS 5 or CentOS 6 installations, and they don't have time or they don't dare to update those installations. And they don't have just time, or they are completely overwhelmed. So if you are in this situation, don't lose your head. Don't start to drink and sleep on your servers, and just pay attention, because this can be very useful for you. So, well, first of all, I'm going to introduce my home institution, which is the person who's paying the bills, so it's important. And I came from the Institute for Theoretical Physics in Madrid, which is a pretty new center. It was created in 2003, and it is the only Spanish center dedicated entirely to research in theoretical physics. The center is pretty new, but we have the highest levels of excellence in research. A proof of that is we have been awarded twice with the most important prize in Spain of excellence, which is the Severo Ochoa. So we are very proud of it, so I have to mention it. So we do pretty cool stuff in there. We do simulations, APC simulations, about the origin and the evolution of the universe. Yes, time travel, black holes, all very cool stuff. Dark matter and energy search, and also elementary particles. Everybody maybe knows about something about the Higgs and all that stuff. So we did things on it. And we have several APC resources. Sometimes we externalize the simulation, but sometimes we run them on site. And we have our main cluster is called Hydra, and it's not a big cluster, but it gives big problems. And this is not the cluster; it's just a abstraction. And it's made of 100 compute nodes, and well, it's not very big, but it's complete. It has all it should have. And it has the InfiniBand network and a Lustre file system. Okay? So, we met all conditions in demo dimensions were met by my institution. So we have non-full-time dedicated APC system admins. We were stuck with proprietary cluster site, and we didn't know what to deal with it. And we had an heterogeneous cluster made of parts, and we needed new hardware at the time. So, and we followed this policy, which is pretty good and pretty bad at the same time. So we ended, instead of that powerful Hydra, we ended with this Frankenstein that is made of parts and is old. So that was our cluster back at that time. And we were stuck also with CentOS 6, and we didn't dare to update. Till we find this piece of software, which is OpenHPC, and it was the solution to all our problems. So what is this OpenHPC thing? Well, it's not a proprietary stack, which is good. It's It's all open source software. It's a collaborative project by the Linux Foundation. And basically, it is a repository, just a single repository, which is very important because when you are installing a new cluster or updating a new cluster or changing something, you are gathering pieces of software that are scattered around. And OpenHPC provides just a single repository with all reference and modern open source APC software known by the community. And it also has very important and awesome documentation. They have awesome step-by-step guides, so it's very easy and very fast to get OpenHPC working. So these are the main components that you can find in the repository. Now OpenHPC is in the version 1.3, and the base operating system support are CentOS 7.3 and SUSE Enterprise Linux. We are using CentOS 7.3 right now, and these are software you can find. You see, you have administrative tools, Ganglia, Elmo, Command, Negios, PDS, EasyBuild, and SPAC. We are having talks tomorrow about those. It has a provisioning tool, it has resource management, SLARM, PDS, other stuff, last clients, I don't know, software, a bunch of software, and then Valgrind. Okay, so it's pretty complete. So as I said, it has several advantages for us at that time, and the main one is that it's all open source and it's modern and well known by the community software. So you don't find anything weird in it, in that repository. You activated it just by enabling a repository. You don't need to compile anything, and it's totally reversible. So every package in the repository has an APC suffix, and you just use wildcard removal with jam or whatever, and you just remove everything if you don't like it, or just start from the beginning. And you can choose the components, can be add, replace, skip. So you are not forced to use all the packages in the repository. And as I said, there is awesome step-by-step guides and documentation, and each guide has associated an automation script that you just run. You just change some variables according to your preferences, run it, and you deploy the whole cluster. So okay, this is maybe hard to believe, but I'm going to try with the help of my personal secretary, Nico. So I want to try to deploy a cluster with 2 compute nodes and a master from scratch in just 50 minutes. So put a timer, and let's see if oh yeah, a timer. So from scratch. So first of all, which is the typical architecture of an open source or OpenHPC system. So as I said, it has a master and some nodes. the master runs as minimum, run these services, the Slur Manager, Werewolf, which is the provisioning tool, DCP, the TFTP, NFS, with the sports two folders, home and this folder over there. And these things are stored to the nodes. There are these clients by default. You can do it. I mean, the default configuration for OpenHPC is a stageless cluster, but you can optionally do it stateful if you like. So, and of course, we don't have InfiniBand system, last trigger, or whatever for the demo, but you can add it in a real environment. Okay, so now the first part. So in order to avoid the demo effect, I just recorded myself a couple of days ago in a more controlled environment. So but this is real time. I mean, I could have edited the videos a bit more. Maybe you find them a bit tedious sometimes because it's downloading a lot of stuff. But I would rather like to see you real time, okay? To see them real time. And Hugo, please proceed.
My pleasure.
You're wasting time, man. Come on. So, okay. Oh. Well, I have 3 virtual machines here. One is running and 2 are off. This is the master, and it only has the base minimal CentOS 7 installed in it. And the other 2 are just 2 machines that are diskless. As you see here, they don't have any disk. So we start with the master, just base OS, and we add to the ATC host just the machine name to let him know who is it. Then we add the repo. I told you this is the OpenHPC repository. You just add it. Okay, it's pretty standard. We start the base system for OpenHPC and the Werewolf tool, which is the provisioning tool, as I told you. So I just group install the base. You see everything is called OpenHPC or whatever. Oh, the video is stuck.
Is it stuck?
Yeah.
Do you have the other ones here?
Yeah. The desktop. Sorry for that. So go a little bit forward.
Yeah.
You know how?
Is important this part?
No, you can skip. Okay. Forward.
Here.
Oh, okay. Okay. So it is installing the base system. So I avoided the demo effect, but not the video effect.
Not the video effect. This is the screen is sorry.
No, it doesn't matter. What is the full screen?
This Windows is.
So sorry, this is the biggest one. The other goes much faster. Yeah. Now I'm installing the Werewolf tool, which is the provisioning tool. You know, it's the application in charge to provide the compute image to the nodes, also to generate it. Okay. So now I install the resource manager, Slurm. In this case, you can also install PBS Pro. This is installed Munch because it's, by default it's authenticated. Use Munch as authentication. So I just edit the slurm.conf file just to adapt to my configuration. I mean, if you had a previous one, you don't have to do this thing. Just for the demo. So I say that I have 2 nodes instead of 4. And I say that they have just 1 socket and 1 core per socket. So after that, I will edit the provisioning master node, the configuration, just to set the interface. I mean, the default interface for provision is ATH1, but it's not suitable for my virtual machine. So I just put the appropriate interface. And then I just activate the TPTP to deploy the images to the node, the bootstrap image. So I just enable some services. You know, I just copy pasta. I mean, I'm doing copy pasting from the documentation. So all these commands and all these steps are in the step-by-step guide. So I'm now initiating the database for Werewolf. I mean, Werewolf use a database for node information store, provisioning information store. So it's initiated here, and I make a pair of SSH keys for to access to the nodes. And I'm almost finishing. So now I'm creating the sports to the nodes that I told you. This is pretty standard also. So here you are. So that's all. I mean, with this, I have this master node completely configured and installed. So please get ready.
Second video?
Yeah, second video. Now we are going to make our compute image, and we are going to deploy it, and we are going to boot the nodes. So we first make a folder for our compute image, just to store all the information in the image, and create a variable with this path. So we build the initial base OS, which is minimal CentOS 7.3 for the nodes. Okay. So it's done a lot of stuff. So I will put the videos online if someone is interested. So now I have the base OS for the computing nodes, and now I install the OpenHPC compute nodes base in the folder. I install the Slarm client in the image for the compute nodes. Okay. Kernel. The modules. I copy the SSH keys I previously generate. And the mount points. That's an important thing. I mean, the way that OpenHPC works is that Werewolf keeps synchronized some special files in the system. One of them is the password file. So password file is distributed among the computing nodes and is kept synchronized with the master node. And the other ones are groups, shadow, slarconf, and munch key, which are the files that must be kept synchronized in the complete cluster, in the whole cluster. Okay? So now we just assemble the bootstrapping image. This is the bootstrap image to be provided to the nodes. And then we make the VNF system. And that's all. I mean, the image is ready. So now we are just going to add our nodes to the data store with this command. I mean, Werewolf commands are pretty nice, so are very understandable. So we just added two nodes, C1 and C2. Yeah, we have it with the corresponding MAC addresses. And we are going to say provision image for the hosts. So we just say that we want these two hosts to have one provision image, which is we say set these two nodes to this image with this bootstrap and with these files. And we see here two nodes provisioned with bootstrap and BNFS and with the files. So that's all. We restart the DCP, we update the PXE, and we just boot the nodes. So we just finished. I mean, booting these two nodes, we just have the cluster. 2 minutes left. So I'm sorry for all this installation stuff, but I just wanted that for once in your life, see how it is installed and the time it really takes. So now you see, the two nodes are booting. They are diskless, so they are going to boot and they are going to remain stateless. So here you are. C1 is booted and the prompt is there, and C2 also. So I want to show you that they are completely up. And that's all. I mean, we have the cluster configured. So that was pretty fast. So please enable the last video, which is not, it's just 2 minutes. It's not cluster configuration. It's just to show you how to run and how it runs. So we just have booted the nodes and we just start the resource manager, the client in the nodes. We see we have a partition with 2 nodes. We install the devel just to run in the and to compile, sorry, in the master node. You can install a lot of stuff here. So easy build, Spag, a lot of stuff. Intercompilers, whatever you want. You see, every single package has this OpenHPC suffix. Just if you want to remove it. So here we go. Sorry, more defaults. So here we go. Now we can run. We just install all the development tools, the minimal ones. We just use a test user, and we use this command to resync the password, the shadow, and the group files. We log in as the user. We see we have the modules available, the module list. And we did nothing. I mean, this is just for free. So now let's compile something. We have some samples here in that folder. MPICC is working. The partition is idle. So I just do an iterative run. So I log into C1. I run my stuff. And it complains a little bit because I don't have InfiniBand devices, but it runs at the end on the Ethernet, and this is the expected output. So that's all. And just put my presentation on a bit. Sorry. Just conclusion left. I mean, you see, it's very fast. It's open source, and it's very, very, very flexible. And that's are the pros and the cons. I couldn't find. I've been using it for a year and I couldn't find. I was thinking about because I wanted to say something more negative or whatever, but it was difficult for me. So because I've been using it for a year and I'm pretty happy, and it made my life more easier. Okay, so that's all. Thank you.
Okay, thank you, Andres. Time for a quick question, or none.
Yeah, Does your cluster has graphic accelerators or any kind of unconventional hardware?
Well, we have Intel Xeon 5 accelerators, but they are out of this OpenHPC cluster. We didn't try them on this OpenHPC configuration.
Okay, because I have heard comments that the OpenHPC stack is very convenient, as you just shown to us, for Intel machines. But from the moment you start having a little bit more unconventional hardware, like ARM processors or GPUs, CUDAs, etc., the software stack is not as good. Do you have any comments on that, or people that have told you similar things?
Yeah, I have a comment. They actually, they actually have support for not only Intel processor, also AMD processors. I mean, any x64 architectures are supported, and they have a beta for ARM processors, and they have in the roadmap to have a release maybe in the following months for ARM. And CUDA and all the stuff is not in the roadmap. I think, I mean, I'm not an OpenHPC employee, so I know the deep details. I don't know them, but I know that they have something in the roadmap.
Okay, I have some questions, but we'll have time, so we'll talk later.
Okay, we got that.
Thank you, Andres. Now it's time for the coffee, but we are going to do the group picture. So we have to go down the stairs just to the main entry of the place, and we'll